Breaking news. At precisely 0412 UTC this morning, a routine sky sweep by the Atacama Large Millimeter Array in northern Chile detected something that should not exist. An object catalogued months ago, an object that every orbital model said was already gone, had reappeared, bright, coherent, and accelerating. Within minutes, independent confirmation came from Hawaii, then from the Canary Islands. By the time the alert reached mission control desks across 3 continents, the impossible was no longer theoretical. Today, the impossible just happened. An interstellar visitor known as 3I Atlas was supposed to have exited our solar system forever. Instead, moments ago, it was detected still here. And this changes everything we thought we knew. If you want more real-time cosmic updates like this, stories unfolding at the edge of human understanding, hit like, subscribe, and stay with us. Because what you're about to hear is not just a mystery, it's a warning written in the language of physics. Before we go any further, we need to establish why this detection has sent shockwaves through the scientific community. This is not a fringe observation. The data did not come from a single telescope or a single country. The first alert was triggered by almost Band 6 receivers operating in the 211 to 275 GHz range, optimized for cold dust and distant objects. Within 8 minutes, NASA's Jet Propulsion Laboratory cross-checked the coordinates using the Deep Space Network antenna in Goldstone, California. 11 minutes later, the European Space Agency's tracking station in New Norcia, Australia, locked onto the same target. 3 continents, 3 independent systems, 1 impossible result. At Harvard, computational astrophysicists halted ongoing simulations to rerun orbital models that had already been closed and archived. At Caltech, graduate students watched as their screens populated with data that contradicted months of peer-reviewed consensus. The Hubble Space Telescope, still operational despite its age, was retasked within the hour, and when the James Webb Space Telescope aligned its near-infrared spectrograph toward the coordinates, the confirmation became unavoidable. 3I Atlas was not only still present, it was active.
3 months ago, 3I Atlas made headlines as only the 3rd confirmed interstellar object ever detected passing through our solar system. Unlike ordinary comets bound to the sun by gravity, this object arrived on a hyperbolic trajectory, its velocity far exceeding solar escape speed. Initial measurements clocked it at approximately 58 kilometers per second relative to the sun, entering from above the ecliptic plane at an angle no native solar system body could sustain. Spectral analysis showed an unusual composition, carbon-rich, but with metallic traces that did not match known cometary profiles. Still, at the time, the conclusion was conservative, a rare interstellar comet, fascinating but natural. 48 hours before its predicted perihelion exit, tracking data showed nothing alarming. Its brightness was fading as expected, outgassing rates dropped, its coma thinned. Models projected that within 72 hours, 3I Atlas would be beyond 12 astronomical units, effectively invisible to all but the most sensitive instruments. And then, right on schedule, it disappeared. No signal, no reflection, no residual trail. The final line in the official log read, "Object exiting solar system. No further observation required." That should have been the end of the story. 11 hours after its last confirmed detection, something strange happened. A weak, transient radio spike was recorded by the Atacama Cosmology Telescope. It lasted just 0.7 seconds, centered at 1.42 GHz, the hydrogen line frequency. At first, it was dismissed as noise, Earth-based interference, a satellite glitch. But the signal repeated, exactly 11 hours later, then again 11 hours after that. 3 pulses. Identical strength, identical duration, identical frequency. No natural astrophysical source behaves like that. As analysts combed through archived data, a realization began to spread through control rooms and research centers. These pulses aligned spatially with the last known trajectory of 3I Atlas. The object hadn't simply vanished, it had gone silent. 26 hours after the 3rd pulse, the first optical anomaly appeared. A faint point of light, magnitude 24, detected by the Pan-STARRS telescope in Hawaii. Too dim to be a comet, too slow to be a star, and moving against the background at a rate that made no sense. Its velocity had dropped to 31 kilometers per second, nearly half its inbound speed. No gravitational interaction could account for such deceleration. There were no planets nearby, no solar braking mechanism that strong. According to every known law of physics, 3I Atlas should not have been able to slow down. Yet the data was clear. At 0318 UTC, Hubble confirmed the detection. At 0347 UTC, JWST provided spectral confirmation. The object's surface temperature measured at 410 Kelvin, far warmer than expected at its distance from the Sun. And then came the detail that turned concern into alarm. Its shape had changed. Early observations had described 3I Atlas as elongated, cigar-like, approximately 230 meters long. The new data showed something else entirely. A compact, symmetrical structure, roughly spherical, with a radius of 90 meters. Comets do not become more symmetrical over time. They erode, they fragment, they shed mass chaotically. What we were seeing was the opposite, a transition toward order. Teams at NASA and ESA initiated emergency modeling protocols. Gravitational simulations failed to reproduce the trajectory. Thermal models could not explain the heat signature. Spectroscopy revealed intermittent absorption lines consistent with indianized metals, nickel, iron, and traces of something else that did not match no natural abundance pattern. One internal memo used a word rarely seen in official documentation: controlled.
Dr. Elias Moreno, a computational physicist working with ESA's Planetary Defense Office, described the moment quietly. "I remember staring at the data feed," he said, "and realizing that every assumption we'd made was wrong. This object wasn't behaving like a passive body, it was responding." Two hypotheses quickly formed. The first was the safe one, a natural explanation involving exotic physics. Perhaps 3I Atlas was a fragment of a larger interstellar body composed of ultra-dense material. Perhaps its deceleration was the result of outgassing jets acting like thrusters, aligned coincidentally in a way that mimicked intent. Maybe the radio pulses were a rare maser effect, amplified by its rotation and composition. Unlikely, but not impossible. The second hypothesis was discussed only behind closed doors. What if 3I Atlas was not a comet at all? As debates intensified, a second wave of anomalies arrived. At 14:02 UTC yesterday, magnetometers aboard 3 Earth-orbiting satellites recorded a brief but measurable disturbance, a spike of 0.8 nanotesla, localized, directional, and aligned with the object's new position. Solar activity was minimal. No coronal mass ejections, no geomagnetic storms, and yet Earth's magnetic field had responded. Then the pulses changed. Instead of a single burst every 11 hours, radio telescopes detected a sequence, short, long, long, short, repeating. When the intervals were translated into numerical values, a pattern emerged, prime numbers, 2, 3, 5, 7, repeating in a loop. This was no longer random, it was structured, intentional. Inside mission control rooms, voices dropped. Conversations stopped mid-sentence, because mathematics is the one language the universe does not fake by accident. As if responding to the growing attention, 3I Atlas did something else. It changed course. By a margin of just 0.3 degrees, its trajectory shifted inward, toward the inner solar system, toward us. The adjustment required an energy expenditure equivalent to detonating several hundred megatons of TNT. No comet possesses that capability, no asteroid, and yet the maneuver was precise, efficient, minimal. At this point, agencies went silent. Public statements were delayed, data releases slowed. Internal communications were encrypted at levels typically reserved for planetary defense scenarios, and outside the scientific community, subtle effects began to ripple across the planet. Low Earth orbit satellites reported intermittent communication dropouts. Shortwave radio operators noticed unexplained blackouts at specific times, always coinciding with the object's pulse cycle. Migratory birds in the southern hemisphere altered established routes, deviating by hundreds of kilometers. Instruments detected faint electromagnetic noise in frequency bands normally silent. Nothing catastrophic, nothing obvious, just enough to suggest interaction. Then, 17 hours ago, one fragment vanished. High-resolution imaging had revealed that 3I Atlas was no longer a single object. It had divided, not explosively, but cleanly, into two components, separated by exactly 1.6 kilometers, maintaining synchronized motion.
And then, without warning, one of those components disappeared from every sensor simultaneously. Optical, infrared, radio, gravitational. It did not move away, it did not fade, it was simply gone. This was the moment the conversation changed, because disappearance is not fragmentation and it is not destruction, it is something else entirely. Now, in the quiet aftermath of escalating alarms and unanswered questions, we are left to reflect. Humanity has spent centuries scanning the skies, asking if we are alone. We imagined first contact as dramatic, unmistakable, overwhelming. But what if it is subtle? What if it arrives not with a greeting, but with persistence? An object that was supposed to be gone, choosing to stay. Maybe we're not witnessing the end of certainty, but the beginning of context. A reminder that our models describe only what we've seen before, not what is possible. Perhaps this is not an invasion nor a message, but an invitation. Or perhaps it is a test, a mirror held up to a civilization still learning how to listen. As of this moment, 3I Atlas remains within observational range. Its pulses continue, its trajectory is stable, and its purpose, whatever it may be, remains unknown. The last data packet received showed a final adjustment, a pause, almost as if it is waiting. So the question now is not whether it will leave. The question is, what happens when it wakes up again? Subscribe to stay with us, because this story is not over.